Hello everyone, this time we're going to discuss some examples on limits and continuity of functions. So the first example would be to indicate whether the limit of the following function exists or not. It is the function at x equals 2x squared, where x is greater than or equal to negative 1 but less than 1, or f of x is equal to 3 minus x, where x is less than or equal to 1 but less than, or x is greater than or equal to 1 but less than 2. So for the solution, we consider the following. If we take the limit of the function as x approaches 1 from the right, notice that should be a value if it's from the right. We should consider the value. Let me use my pen here. Okay. So we should consider if it's from the right, this is 1. You approach it from the right. So mean to say it should be a value which is greater than 1. If it's greater than 1, then it should be this. So you have to make use of 3 minus x. Okay? Because this function value here is greater than 1. And that should give us, you substitute now your value which is 1. That is, 3 minus 1 will give you equal to 2. When you take the function as x approaches 1 from the left, so if it's from the left, then what do? It should be a value which is less than 1. So it's a value less than 1. We should make use of this function value here, which is x less than 1. So 2x squared. That is, we take the limit this time of the function as x approaches 1 from the left, make use of 2x squared. So when you substitute this time your 1, that should be 2 times 1 squared, which is equal to 2. Notice that you have the same value as of the function f of x as x approaches 1 from the right and 1 from the left. Therefore, the limit of the function exists. As for the second example here, you're asked to determine if the given function is continuous at the indicated number a. So if it is discontinuous at a, you are asked to determine if the discontinuity is removable or essential. If you take the function, you have h of x equals 1 plus x when x is less than or equal to negative 2. Meaning to say, if you take a look at the graph here, this is your negative 2, then these function values are x less than or equal to negative 2. So it should approach negative 2 from the left. On the other hand, this one, you have 2 minus x. h of x equal to 2 minus x when x is, okay, here, x is supposed to be greater than negative 2. So if this is your negative 2, okay, should be greater than negative 2 and x is less than or equal to 2. So it should be greater than negative 2. All values which are greater than negative 2, so all the values here, greater than negative 2, it's approached there, approaching negative 2 from the right, because it's greater than negative 2, now x approaching negative 2, and it is x is less than or equal to 2. So from negative 2 here, you have less than or equal to this is your 0, and this is your positive, say positive 2, all values x less than or equal to 2. So less than or equal to 2, approach there 2. On the other hand, this one, you have x is greater than 2. So if it's x is greater than 2, then what do we have? 2x minus 1, x is greater than 2. So if this is your 2, all values approaching 2. So you have that one, x is greater than 2. So if we're going to compute for the continuity of this function, then what do? First, when we are asked to compute the continuity at x equal to negative 2, then we consider the function value, that is h at negative 2. And because if you take a look at the sketches here, x will be equal to negative 2 if you have h of x equals 1 plus x. So you make use of that one. 1, this is your 1 plus x. But our x is negative 2, so you have equals negative 1. So it exists. Then the second thing that we have to consider is to find whether the limit of the function at negative 2 exists. So, and how do we do that? We take the limit as x approaches negative 2 from the right and from the left. So, if it exists, then we take the limit of the function as x approaches negative 2 from the left. So, from the left, if you approach it from the left, then you make use of this function, because this one approaches function the x at negative 2. So make use of 1 plus x. So you have limit of 1 plus x as x approaches 2 from this is from the left. So you can now solve for that one, and that is 1. Then your value is at negative 2, so you have 1 minus 2, and that should give you equal to negative 1. On the other hand, if you are asked to, since you're asked to find out whether the limit of as x approaches negative 2 exists, and you also need to solve for the function values, that is the limit of h of x as x approaches negative 2 from the right. And to do that, notice that if it is from the right, then approaching from the right, negative 2, we make use of this. Make use of this. Okay, this is approaching negative 2 from the right, so this function make use of 2 minus x. So you have 2 minus x, and substitute it with 2. You come up now with equal to 2 plus 2, which is equal to 4. So notice that the limit of h of x as x approaches negative 2 from the right, and as x approaches negative 2 from the left, are not equal. In this case, you have actually a limit which does not exist, so that the function has an essential discontinuity at x equal to negative 2. Now, the next thing that we have to consider this time is to take a look at the function, whether it's continuous at x equal to 2. And we are going to do the same thing, that is, we're going to find out first the function at h equal to 2, and then take the limit of h of x as x approaches 2. And to do that, we have to consider as x approaches 2 from the right, and the limit as x approaches 2 from the left. So let's take a look at the solution. So we have it's the same problem, except that we're going to evaluate it whether it is continuous at x equal to 2. So at x equal to 2, then if you take a look at x equal to 2, what do we do here? You have at x equal to 2, the function value is this one. You have x equal to 2. So you make use of 2 minus x. Plus this one, you have x equal to 2 here. So you have h at, you have 2 minus x. This is actually your 2 minus x. But this time your x is 2. So you have 2 minus 2 equal to 0. It exists. So the next thing that we have to consider is whether the limit of the function exists. That is, the limit of h of x as x approaches 2 exists. And to do that, again, what do we need to do? You have to consider the limit of h of x as x approaches 2 from the right. So let's take a look at this one. We'd like to approach it 2 from the right. So this one will be approaching 2 from the, this is x is less than or equal to 2. So it approaches 2 from the left. This one here, you have x is greater than 2. So 2 you have x approaches 2 from the right. So what are we going to make use of? If we take the limit function value as x approaches 2 from the left, we make use of this one. 2 minus this one, 2 minus x. So that is equal to the limit of 2 minus x as x approaches 2 from the left. So that will be 2 minus, substitute with 2, come up with 2 minus 2, which is equal to 0. On the other hand, the other one, limit x approaches the function as x approaches 2 from the right, so it should be greater than 2. So make use of this one, x greater than 2. So x greater than 2, meaning to say you have to make use of 2x minus 1. So take the limit of 2x minus 1 as x approaches 2 from the right. To give us 2 times 2 minus 1. So it's equal to 4 minus 1, which is 2. So again, in this case, you have two values which are different, so that the limit of h of x as x approaches 2 does not exist. And because of that, we come up with an essential discontinuity at x is equal to 2. Okay, so it means to say the function is actually discontinuous both at x equal to negative 2 and also at x equal to 2, and because the limit does not exist for the function values of these 2 points, then that means that this function is discontinuous.